Thank you for the opportunity to present research today that we've been working on for the last, honestly, 10, 15 years. It's a big research area of mine, and that is how do we promote precision turfgrass management with use of technology? So I'm Bill Kreuser. I'm an extension specialist at the University of Nebraska, and I'm the co inventor of Greenkeeper app, a decision support tool that we designed to help superintendents make better agronomic decisions. So today we're going to kind of dig into how can we use this technology currently, and then what are some opportunities for research that we could fund in technology improvement and development could we invest in to promote sustainable practices with precision turfgrass management. So precision turfgrass management is a real simple idea. Just only apply products when you need to actually apply them. But unfortunately, a lot of times turfgrass systems are extremely complex, but then we oversimplify them. So we just say, here's a 4-step fertilizer program, say for home lawns, or you water to this amount of ET in all situations and you should be fine. And so as we're trying to become more precise, we need to be able to get rid of these generalizations and start measure how the turf is performing so that we can improve practices. And so things like when to put down pesticides or irrigation, how do we schedule fertilizer applications, or even better, how do we apply fertilizers to spots on our turf facility, our golf course, our sports field, only where it's needed and not where it isn't needed. And then, how do we use things like growth regulators to try to dial in our growth rate? And so this is a big area of research in my lab and with people that I do research with around the country. One thing we're really seeing a lot of recently in all of agriculture, but now it's coming into turf, is automated sensor networks. And so instead of having maybe one weather station or one point of weather data from a website like weather.gov, we're seeing the ability to have weather stations and soil sensors placed around a turf facility, around a golf course, all communicating with each other and communicating up to the internet, to the cloud, so that a lot of data can be generated all the time. And we can also, place different sensors in different microenvironments. So we can maybe understand what is the humidity and weather like in one spot versus a different spot. And so we're seeing this, starting to become widespread, but what it leads to is a lot of real big data. This is that word that people throw around a lot, this big data idea. And ultimately it just means we're bringing in so much information that it really takes the turfgrass manager, the superintendent, more time to just organize and visualize and think about the data than they might actually get benefit out of it. And so in order to get over that bottleneck, that's where I started developing this Greenkeeper app back in 2015, so that it would take the data being generated by the user, like pesticide application data, fertilizer addition data, and pair it with weather data and different types of sensors, and let the computer algorithms to help to guide management. So what we'll talk about today are some specific examples of some opportunities that we're currently using with Greenkeeper, but a lot of what we're going to talk about today is things that maybe further down the road. The weather-based models have been around turf for decades, starting with things like growing degree day models to time seed head control. Then we are seeing models, kind of growth potential models that use temperature to predict how aggressively the turf grass will grow or respond to fertilizer. And then we've seen some of these newer types of models that take a lot more data collection and analysis, but then we can derive a lot of really cool and useful information from that. So that's new disease models like the Smith-Kearns model, in which all they did is really closely monitor outbreaks of dollar spot and then use logistic regression to figure out what weather factors were most important to predicting an outbreak. And one thing my lab has been doing since 2008 is understanding how growth regulators and now DMI fungicides impact the growth rate of grass. And so all these models use weather data, and these weather networks are really helpful for us to improve that. And the next real step there is how do we link a network of these stations together so we can reanalyze these models across different microclimates on a golf course. Now we're seeing the hardware side coming into the precision turfgrass management. And so things like TDR meters, This is a pretty good success story of precision turf management. They really weren't even in the turf industry 15 years ago, and now they're widespread, and we're seeing in-ground sensors. The one problem with these are they only measure though at individual spots. And so one of the technologies that we just kind of looked into was using infrared thermography or thermal cameras to actually see the heat across an entire turfgrass area. Turfgrass temperature is directly related to heat because the hotter the turf is, that represents a lower level of transpirational cooling. And so that would suggest there's either some kind of a root issue or more likely there is some limitation on water. And so as those stomata are open and we're transpiring and there's soil water available, that grass is going to be cooler than grass that is not transpiring because it has a deficit of irrigation. So we've been working with technology, the TurfView Hawkeye system that is mounted on a tree or a building, and that has a thermal and a visual camera on it. And we are looking at different types of irrigation replacement and trying to understand what the thermal signature is of these turfgrass plots as they dry out. So here's a graph of grass that is well watered in green, and red is not watered. And so we see a nice dry spell happen in Nebraska in the summer of July of 2018, and a real rapid reduction in the volumetric water content over time. And so if we're doing traditional management, we would see the grass is green, doesn't need water, and then it starts to wilt and we would go water it. But can we use thermography to try to figure out a day before we see the wilt when we need to water? Or can we build a water type index that can help to predict when we have to water? And we think we can. So here's looking at the canopy temperature minus the air temperature. So in the daytime, when the canopy is a little bit warmer than the air temperature, and then at night it cools actually below the air temperature due to radiational cooling effects. And so we see as the canopy is starting to dry down, that window between green and red, there is a slight increase in that temperature. And so we think that we can detect this, and by doing so, reduce water use. So TurfView has been working on a stress index, and in our research, we found that we were able to reduce water inputs by 75% just by scheduling irrigation right before wilt, when we were able to use thermography, versus 100% replacement in which we were measuring the water loss and then replaced it every single day. So a lot of potential there for that technology. Finally, we'll wrap up with technology to guide nitrogen fertilization. And so this is kind of in drones. The turfgrass industry is heavily reliant on historical fertilizer practices. And the problem is recommendations are always changing. So there's been kind of a push to use drones and other passive sensors. The limitation there is, one, they're drones, and so that you need to have certain airspace requirements and operator ratings. And then the other big part is they're passive. And so they're measuring NDVI, an index that really is problematic in turf setting because it becomes saturated at 100% canopy cover, healthy turf. And also it's passive. So time of day is very, very important. So one of the things that we wanted to look at is to go away from these passive indices where you can see even the lines from the mower showing up, which really isn't reflective of true differences in biomass. That's just the light reflecting on a passive meter, to go to an active sensor. And so we've used a Holland Scientific ACS 430, and we've attached it to our fairway mower. So every single time that we mow, we can go collect data, and not just NDVI data, as NDRE, an indices that's very good for measuring the amount of chlorophyll in the plant, which is highly correlated to nitrogen status. So in doing so, we're able to make these great maps that show areas of high and low chlorophyll concentrations. And the nice thing about NDRE is that it's not very sensitive to irrigation levels. So it really is a reflection on nitrogen status in the plant. And then so from that, we can make these nice types of graphs where we can schedule different levels of fertilizer very simply as based on the NDRE. And we set thresholds based on individual sites. We don't just say that you can apply these everywhere for different factors like cultivar, and other things like, maybe disease or compaction issues. And so to kind of really optimize this, we've done new experiments to understand variability, both in a controlled setting and across a real golf course fairway. So if you look really carefully, you'll see the white dots across these fairways. So we're actually sampling across fairways to get an idea of spatial variability. And then after we do that, we make spatial maps of different levels of fertilizer. And this is our variable rate sprayer from Frost Inc. And so you'll notice that the nozzle's turning on and off, but they're also going to higher and low output levels to vary the amount of urea we're putting down across this fairway as dictated from our sensor. So finally, we're trying to take all these sensor data and algorithms and put them right into our Greenkeeper app and apply machine learning to really optimize applications at individual golf courses and to really improve the performance of our models. And so that's a big push to get the technology from the hardware stage to software that is really usable. And so from a research opportunity to expect where the hardware is there, we're seeing agronomic models being developed that can really increase precision. But we need more research in figuring out how to turn the sensor data into actionable management recommendations. And then how do we get all those sensor data to be integrated across platforms to maximize the benefit to the turfgrass user and to be intuitive and easy for those users, so it really isn't burdensome on their time. So with that, if you have any more questions, you can reach me at bill@greenkeeperapp.com or at wkreuser2@UNL Turf, and I look forward to a great discussion.